Okay, I'm going to show concept of a bucking transformer that picks up the ambient flux. So you have a U-shaped core, maybe out of ferrite be good, and another U-shaped core. Okay, now you wrap winds around here, maybe that far. Same thing here, wrap winds around here, maybe that far. And wrap winds around here and here. These are going to be north against north. These will be south against south. Okay. Now looking at the top, if you look at the top view here, here's the core. And so the wraps would be around, here. This is the top view. And also there'd be actually 4 leads, looking from the top. Okay. Now, what happens is that because it is it's north against north and south against south, when you energize this coil and this coil, it makes the flux shoot out the sides. Comes out the sides. I call it splatter flux. It splatters outwards. And it goes nowhere. It's just lost in space. Some of it might reach back around. But so what you do is from the top view, these are pointed right at the air gap. You put thin ferrite cores all the way around that air gap, pointed right at it. Same with this one, all the way around, pointed right at the air gap. Okay, now, so that looking at it this way, these would be like pointed here, they'd be like here. Okay, so these are 90 degrees to the core and the air gap. But also put another ring of, I'll call them splatter coils, let's call them pickup coils. Put another ring at 45 degrees all the way around, also pointing at the air gap. Okay, and these go all the way around. So let's say you have 20 at 90 degrees, and then you'd have another 20 at 45 degrees, and then below at 45 degrees, so another 20. Let's just say you have 20, and that'd be like 60 coils, 60 thin ferrite cores pointed at. Now each of the coils, this would be time consuming, but each of the cores has wraps around them. Each of them. So all the cores get wrapped with magnet wire. So they're going to make some power when this thing gets pulsed. And that flux shoots out the sides. Okay, then put a diode on each one and fill a cap. So every one of these has a diode. So you're going to need about 120 diodes and 120 caps, little caps, but you can probably put it all into one big cap. I don't know why not. So that is the idea here, is you're catching the compressed ambient flux of bucking coils. Not the most beautiful drawing in the world. Okay, I'm going to flip over to a computer drawing I made. Just 1 second.
Wait.
Okay, so here's a computer drawing of the same thing. So this is the upper U-shaped core, the lower U-shaped core, north against north, south against south. Now one thing you can do is just do north against north and then have all of this be generator coils all the way to here if you want to do that. But I kind of like it like this. So you have bucking coils here. Here's the air gap right here. And this middle one, this represents the ring all the way around. This is just a flat drawing, so I couldn't really do that very well. And this is the 45-degree ring of, say, 20 of these cores with coils wrapped, filling a cap with a diode, each of them. And you go all the way around, so if each ring's 20, that's 60, so it's like 120 coils. And when you collect power into caps, when you collect the ambient flux, it has absolutely no reaction or reflection to the draw of these coils being pulsed. So if you put a meter on pulsing these coils and it's like 1 amp and whatever, 20 volts, and you start collecting into caps, it's still just 1 amp and 20 volts. It doesn't affect the draw. So I got this idea from my Konehead motors I was making around the year 2000, a couple of years after, a few years before. And it had bucking coils. And I'm going to make a quick drawing of the Konehead coils and in the motors, and I call these splatter coils, what picks up the flux, because it's compressed, it's smashed together, and it comes shooting out the sides with lots of force. And these really pick up a lot of energy. So I'm going to make another skip out of here and make another drawing with Sharpies. Hold on a sec. Okay, my Konehead motors were like this. It's like the EV Gray motor. You have coils on a rotor and you have coils outside. I'll just do 2 stator coils. Here's the coil leads. Okay, so you'd go north, north, and then actually north, north, like that. And so they all smash together. All the coils smash together. Bucking. And what I found with the Konehead motors is if you put a magnet right here, like here, and these are north, and then put another magnet over here, and you make the polarity of those magnets to be so that they change the polarity of this coil and this coil from north to south. That's what you want to do. So this will be rotating this way, the rotors. Okay, these are called regauging magnets. Regauging magnets. Chapter 1 of my book, I have some photos of it and explanations. So what happens is, let's say you do not have these magnets and you energize these coils north-north. Okay, so that's fine. Let's say it's a little bit staggered like this way. So when you pulse them, it whips the rotor around this way. Okay, repulsive. But when it comes up for the next lineup, position to be fired again, north-north, the cores remain north. They don't like suddenly go back to south or some default position. They remain north because this is all happening very fast. So what happens is, upon approach to the coils outside, the stator coils, you have a clash when they approach each other, north against north, and the rotor wants to shove itself backwards. It has to. The only thing that's going to get in the coil position again is the momentum of smashing through that north-north flux. So this is how regauging magnets work. So if you can make this coil become south and this coil becomes south upon approach, now you'll get a traction instead of a clash pushing back. So it makes it like a free power stroke. And also you've canceled out that clash. So it has two advantages. Also a third advantage is the magnet will induce some power in there, like a generator coil too. That's another thing. So I found I could have like 4 times the speed and power when I added these magnets to my motors, and the draw would just go right and like reduce down in half. It was quite a big, I discovered it by accident. Just playing around. It wasn't an accident, I was just playing around with magnets and I go, wow, what happened here? So that's regauging magnets. Now, back to the bucking coils. I'll go down here. Now, when you have bucking coils, here's the rotor, here's the stators, so you got north, north. All this juice comes shooting out the sides, Comes right out that air gap, this way. And some of it goes back like a normal, normal flux field. Now what's interesting is this guy who made a looper a long time ago, like during the hippie age, I call this thing a hippie motor. This is where I got this idea. He says if you chop the flux field and look at it in a cross section, what you'll have is dots, and these are the flux lines. It's a field of lines, and he says you'll have thicker ones towards the coils, and then on the outside you'll have thinner ones and more of them, like this. Isn't that interesting? And so when they built this looping motor, he said he used pencil leads, like the old style pencil leads, but he may have meant they were ferrite. It was a long time ago. And they would take clamshells and drill holes in clamshells and stick these little ferrite pencil leads or whatever there are, lining up with how these dots are. And they would stick them on the sides. Like, let's say, here's a clamshell. I don't know if I can draw a clamshell. They'd stick them on the sides like ears. So on a top view, here's the bucking coils. He actually had a magnet and coils. It works with magnets and coils too. And here's where he put the clamshells, like this. And then he had all those holes drilled with all these ferrite tubes, or not tubes, but very thin rods. And he said he thought they were pencil leads. And then each of these has winds around them and a diode. And then he would feed all this back, and the thing looped. And he said he couldn't put anything here because when everything's rotating around, it would get in the way. So he would catch it on the sides. So that's how he made this motor work. And he also said he's a really good machinist, and they actually had a project during the Vietnam War to make AK-47 copies for the American Army to use in assassinations and stuff that sounded like and use the same ammunition as AK-47, so they could shoot Viet Cong and then make people think it was the Russians did it and stuff like that. And Kalashnikov was the guy in charge of this project. This is what he said. I don't know. And he said they put this motor in a cabin, and it was running all by itself, powering this cabin, and Kalashnikov came and took it away. So anyways, what he said is the rotor in this thing, I call it a hippy motor, was 3 magnets from his memory, rare earth magnets, of course. And then he had 2 coils out here. And where they would put these clamshells was right here and right here, where the magnets whip past. I didn't do that very well. Where the magnets whip past the coils. And so he had 4 clamshells with all these ferrite rods, thinner ones on the outside, thicker on the inside. He swore they were pencil leads. Like, remember you used to, like a lead type pencil leads, graphite, whatever. And they used the thinner ones on the outside, more of them, and they had to line these up right with the flux lines. So, and his job was doing machining. They also had some girls doing all the windings and the clamshells and stuff. And he said he didn't need clamshells, it just happened to be a good shape. There was nothing special about clamshells. It looked cool, but it was just a way to mount all those splatter coils, I call them. Okay, so also he said he made out of gold. I used to make roller commutators out of skateboard bearings. And I'd put a little conductive grease in there, and I'd have that hit a brush contact. And he saw those. He go, oh, you know what I used to do is for this motor, he also had a roller, and it would go on kind of a slope contact, and it would spin past this, and it was made of gold. And he says that's how he did the timing, the commutation for this thing. So that's all interesting. So that's where I got the idea for the splatter coils coming out the sides of my motors. And on chapter 1 of my book, you can see some of the splatter coils. I got these very high impedance coils at a surplus place and put some steel iron rods inside of them. That was my splatter coils, and then I clustered them. So anyways, that's probably good enough. I strayed into other subjects, but that's okay. So I guess thanks for watching. Okay, thanks. Bye.